So this is navigating the software delivery minefield, DevOps, and the art of release engineering. And we're going to kind of talk about what that means. And I'm glad you're all here to join me for this today. So this is the obligatory About Me slide. I'm not going to go through it except for a couple points. I'm J. Paul Reed on Twitter, so if I say something confusing or you want to continue the conversation on Twitter, you can find me there. The only other thing I'll point out about this slide is that I'm a Master's of Science candidate in Human Factors and System Safety, and I point that out because you're going to hear human factors and system safety probably in this talk, and that's kind of where it comes from, the last 80 years of research in the safety sciences on this particular topic. So I wanted to start with a little survey for everyone in the room. Who here has release engineers or a release engineering team in their organization? Oh, good. Okay, lots of hands going up. Who here actually knows those people? Like they can find them and talk to them? Okay, good. About half, yeah, all right. And who here is, and I say this kind of tongue-in-cheek, who here is doing the DevOps? And yet, you know, they think that you're making progress, you've got a continuous delivery pipeline, you've got the culture change going on, and yet deploying software is still hard. Like it's still difficult, it's not quite as easy as Netflix and Amazon make it sound. Who is in that boat? I see one hand, yeah, okay, good, there we go, cool. All right, so this, I think you're in the right room for this, all right. So I want to start with a little story. This is a very old picture of a very young me. When I was a release engineer back in the day. And it was funny because I was trying to explain to my manager at the time, who was the VP of engineering, sort of the way that I thought about things and the way that I thought release engineering should be practiced, right? And so I basically said, you know, we're kind of like air traffic controllers, right? We sit at a certain place in the system, we kind of direct commits and releases, and we have multiple different customers, right? Even sort of said, you know, here's like a little game, right? I'm a build engineer, right? And my boss's reaction at the time was something like this, right? Where he's like, what are you talking about? He looked at me like I was crazy. Now, the one thing I would point out is that the interesting thing is most of my classmates, or many of them, are pilots and air traffic controllers in the Human Factors System Safety course. So I kind of actually feel a little bit vindicated that I sort of made that analogy. So a couple of the things that we're going to be talking, or the two main things we're going to be talking about today. Do we have a release engineering problem? And ways to sort of notice that, or yellow flags, even if we're doing the DevOps, even if we feel like we're successful, and even if by a lot of metrics we are successful, is there something about release engineering that is holding us back? People that raise their hand about, yeah, releases are still hard, right? And then the other thing is sort of the art of release engineering that I called it, which is really about human factors. Who's heard of continuous delivery? Yeah, most of the hands should be going up, which is good. So there's an interesting question about like, what is continuous delivery? What's the definition of continuous delivery, right? So a couple of interesting definitions that actually focus on different things. Continuous delivery means minimizing lead time from idea to production and then feeding back to idea again. This is a ThoughtWorks consultant. Of course, people know Jez Humble. Jez Humble, Dave Farley wrote the book. A set of principles and practices reduce cost, time, and risk of delivering changes. My definition is actually a little different. Continuous delivery is your organization, your entire organization, caring about release engineering and QA in a way it has never cared about them before, right? So a lot of times I see when people try to go do continuous delivery, release engineering and quality are kind of the non-functional requirements. We don't really sell release engineering to our customers, and we don't really directly sell quality. We sort of do. But a lot of times these have been chronically underinvested in our organizations for a really long time. So when we go to do continuous delivery, we actually have to start caring about them, right? Or we fall into that trap of we'll just ship bad stuff more quickly, right? Or more continuously, as the case may be. Now, one thing, and this came up actually a number of conversations here at DOES, release management is not release engineering. So do we have any release managers in the room? Okay, a few hands go up, yeah. I am not talking about release management. Release management is super important, but I'm actually talking about the release engineering. So the scripts and the tooling and all of that gets written by engineers, supported by engineers. A lot of times you see it, the artifact they produce really is the continuous delivery pipeline. So what I want to go through is actually some release engineering smells, if you will, in your environment. If you run into these, it may be a sign of some of the troubles, and these are the troubles that I see in a lot of organizations that people have when they do continuous delivery, when they do, quote unquote, the DevOps. Rel eng smell number 1, modern version control chaos. What do I mean by this? Well, I mean Git and GitHub. People have this, right? So who here uses Git, right? All the hands should go up, right? Because that's the new hotness. Actually, it's not that new anymore. But what's interesting is, has anybody ever looked at their commit history and they see this? Like, that is our branch structure now with Git, right? All of these weird lines. This is another one that I actually find particularly interesting. Like, I don't know what's going on there, but, and that was actually, I'll just say it. This was on a Reddit, and the Reddit was called Shitty Programming, which I thought was kind of funny. Okay, but what's interesting about Git, right, is one of the things that they kind of tell you about is, well, okay, you should have smaller, more localized repositories. Well, from delivering a product that we care about, this means like an explosion of repositories that we all have to deal with now, right? And we have to find ways to sort of stitch this together, stitch all of these different repositories that now make up our product together. And this can cause real problems in continuous integration and then, of course, continuous delivery environments where we have to basically put together all the parts of our product in some meaningful way. That's actually where, if you're struggling with that, you're not alone. See a lot of that, and that's sort of a major problem that we see today in terms of release engineering. And again, these are all kind of things that release engineers, it's kind of their bread and butter. They can help with this stuff. Release engineering smell number 2. Can someone just tell me what is running in production? This used to be easy, right? We would do the little about dialogue and we'd go, oh, I have version whatever, right? I stole this. So Jez Humble has a continuous delivery gauntlet. This is a configuration management gauntlet, if you will. So what I want you to do is raise your hand and keep it raised, but if I say something that you don't do, then put your hand down. We'll see how many hands are up at the end. So raise your hand if the app that you're responsible for, you can tell me what artifacts are running in production right now. So go ahead and raise your hand if you can do that, all right? Using a unique human parsable identifier. So that's something like a version number or something I could tell you. Good. That is unique to the entire company. Okay. And is traceable back to the commit and action that generated those artifacts in a way that I can define or identify the exact person who wrote any arbitrary line of code in the product, including the open source components that you use. Okay, I see 2 hands, which is good. That's great. Now, what's interesting is, by the way, when Jez Humble does that survey, pretty much the same results, right? When he does it with continuous delivery, his version of that. This is a software artifact, so we haven't really even talked about operations yet. So if we were to look at packages in maybe our environments, right? Who wrote the line of the chef cookbook that we're using, or the puppet manifest, or whatever it might be, right? So this is really an issue that we see where it's actually hard. The traceability here becomes really hard, and part of that is due to the stitching together that we do of repos that we kind of have to because of the way source control works now. Release engineering smell number 3, reproducibility is a problem still, which, so people might say, containers will save us, right? Who's run into, though, this problem with containers? There's a great post by Julian Dunn, who used to work at Chef, and he would talk about the WAR file, right? And he would say it's the enterprise WAR file that we would all mail to each other, and people would like unzip the WAR file and put their stuff in and then zip it back up and send it on down the line, right? And who knows where all this stuff came from, right? And he was saying containers, if we do it wrong, are sort of this same problem, right? People dump stuff in a container and then they compose it and then it goes out to production, right? And what's interesting is that you see we've pushed that reproducibility into the container space, but we haven't really necessarily solved it. Right? How do we reproduce that entire container from the very bottom, right? And this, I'll come back to one of the other kind of problems in the way the services that we rely on where this really bites us. Another one, actually, another example, who remembers NPM gate, where Node unpublished a module and everybody was using it, it broke the internet, right? Part of the problem with reproducibility is we're in such a connected world. We use so many services like NPM, like Docker Hub, like even public package repositories for things like Linux packages, that a lot of times the reproducibility is hard because we don't actually own that infrastructure. We're not mirroring it. We're just grabbing whatever's out there. And we might have a lock file, but we don't actually know what other people are doing there because that's not our infrastructure. Those bits aren't actually within our walls, right? There's a question really about, this comes down to if people heard software supply chain. Who owns your software supply chain? If you ever are curious and need a reminder of the answer, you can go to whoownsmysoftwaresupplychain.com and you'll get the answer. It's you, right? So this is one of the things that from a release engineering perspective, we actually have to care about. We need to start owning our software supply chain. And this comes up in all sorts of interesting cases in terms of problems. The NPM one was an example where it sort of broke a lot of websites. There's a great report from Sonatype on the state of the software supply chain, and that's actually where some of those earlier graphs came from, an explosion of open source projects. They're looking at it from a security perspective, right? So Equifax and some of the really bigger hacks, they go back to like a struts vulnerability, right? That was known for a really long time. There's an interesting story that they tell in here where they talk about there was a bank that had something like 40 different versions of struts in production, and something like 38 of them were vulnerable to a security problem. Now, the thing that I like to say about that is if you have one version of a particular dependency that has a security problem, that's a security issue. If you have 38, that's a release engineering problem, right? So the point that I really want to make here is that DevOps, continuous delivery, lean, the rest of the stuff that we talk about do not directly or inherently address these problems. These are release engineering problems. And one of the interesting things, there was a great talk at PuppetConf this year by their VP of engineering who has an operations background and said, operations people, in the mid-thousands started doing deployments. They became the de facto release engineers. But what we're finding is a lot of people that are responsible for doing deployments, responsible for building that continuous delivery infrastructure, may not have had any release engineering training experience, and it's not their fault. I mean, they did operations, and then somebody said, now you're doing deployments. Congratulations. And that was kind of the point of his talk, is the operations people suddenly took on this new role. But what we see a lot is that because they don't have that experience, they struggle a lot with coming up with things from first principles again, things that release engineers can really help you with. So it's really important. Now, you may have seen in the title, The Art of Release Engineering, and you might go like, art, what does that mean? And really, I want to talk a little bit about sort of human factors and where human factors sort of intersect the work in sort of release engineering and operations. Because this is a new topic that's coming up a lot in a lot of these discussions, and I think it's fascinating where you see these issues pop up. So going back to the air traffic controller analogy that I made all those years ago, it's not that we help coordinate releases, that we build infrastructure, but we sit at a different place in the system, right? We have a different view by the nature of the fact that we are touching different bits, and people care about the product that gets released. So it means that when we come up with a release engineering process, we end up doing a lot of things that turn out to be related to squishy human things, like how humans talk to each other about what's in production, or how humans debug a problem in an environment that, in production when there's an issue or an incident, right? How do they do that and how they do that quicker? Those are all sort of human factors issues. So you might be saying, okay, well, human factors, what do you mean by that, especially in this context, right? Well, really, it's about I was saying this earlier, the operability of a released and deployed product, right? So I'll give you a silly example. If this was your package, let's say you have your software and you package it into RPM, so that's great, good, we're using packages. We're not pulling things directly from Git, which I see a lot. Take it from Git, deploy it right out. You got a package. When was that package built? That's your package name. When was it built? How old is it if you saw it in production and did a package list? You actually can't tell. Now, if I ask the same question with that package name, can you tell me when it was built? Just by inferring from the name. Now, this was an example, actually, that I had an interesting conversation with an engineer because we were talking about, package managers look at these numbers and they know it's an update if it's a higher number, right? So he's like, why don't we just use the number, like 1, 2, 3, 4? And I said, well, if you use a date, you have all this other information you can infer. And he was like, yeah, computers can compare numbers. And I'm like, yeah, I know computers can compare numbers, but this is more human parsable. And there's interesting research that says in an incident, what are things that operations engineers look at? And if they can find out that a particular package maybe is 2 weeks old, and they know that we were supposed to have done a deployment last week, that can shave off a lot of time just by encoding a little bit of information in your package name. So the way that I kind of like to say this, automation, or the point about automation, is that release engineers don't just implement automation, they design automation for others in complex socio-technical systems, right? You'll probably hear this term a lot, more in the coming months and years, socio-technical systems. It's important because the socio part is the people part. We're realizing how important the people part of the work is in addition to the technology. And I have a picture of a checklist here. Another way to sort of think about it is if you look at aviation checklists, this actually is an aviation checklist. If you're talking about something like starting an engine, the checklists aren't designed to like push a button over here and then push a button over here and turn this knob where you're moving about the cockpit. They talk about flows in the cockpit, right? So the procedures are designed such that you can flow from one system into the other in a way that makes sense for whatever procedure you're doing. And it makes it easy for humans to go through that flow. That's actually the term they use, go through the flow, right? So I've seen a lot of organizations that have release checklists, but they don't have a good encoded flow into them. So they make them actually really difficult for humans to execute. And when you have a flow, it's really easy for you to go from one item to the next and say, wait a minute, that thing that's next in the flow or last in the flow doesn't look quite right. And you can kind of reason about that as opposed to being very distracted moving around. And so you might think about if you have a release checklist, is this a problem? Is it a lot of high touch at different points in the system? Another example, versioning. I love version bike shed conversations. So which is easier for two people to discuss? I revision Alpha Charlie Delta 3 Bravo 9er checked out in my Git clone. Which version do you have? Right? Or I revision 28492 synced in my repository clone. Which is easier, right? Here's another interesting question. Which revision precedes these two? Right? So I point this out because if you follow me on Twitter, I will talk about Git endlessly. It's one of my favorite things to talk about. But this is one of the things that makes this a lot harder than it needs to be. And there are reasons in Git why that is. But I want to point it out that sometimes these tools actually can have an impact on our cognitive load when we're trying to have a conversation. And you see this come up like when two engineers are trying to debug something. And I've seen this repeatedly with Git, and they don't have the same versions checked out. And they didn't use the phonetic alphabet, so E and 3 got jumbled up when they were talking, or something like that, right? In their revision when they get it, and it takes a lot longer for them to debug things. Another one, you might say, well, okay, how do you do versioning? Semantic versioning. Who knows about semantic versioning? Yeah, so semantic versioning is basically a set of rules. You have 3 numbers. And the rules mean things, or the rules say the 3 digits mean something, right? And so you should be able to communicate to other people something about your package by the version numbers, right? So this was from Twitter, and this is why this stuff is actually really hard. Semver is, I warned you, .this is shining, .oops, my bad. But then somebody replied, Made life easier for me, made life easier for you, white space. And then I love the question mark, right? And then, yeah, but it's usually, oh God, no, .lol, whatever, right? And so what's interesting is that, we think a lot, especially if you look at release engineering, version numbers are a hard problem. You can't just say, just do semantic versioning, because you're trying to communicate something. And that's the squishy hard part about humans, right? We're trying to encode a bunch of information, trying to boil it down to a version number. By the way, I bring up this example because you'd think that this was a solved problem, but apparently not. The OpenSSL, which that's a thing, right? Security issues with OpenSSL. The release was broken, so instead of bumping the version number, they just refreshed the tarballs and had the same version number with different bits. Please do not ever do that. But again, versioning is really a communications mechanism. That's why so many organizations have different patterns, and semantic versioning may not be the answer for you. A couple other human factors, yellow flags. So opaque stages of the continuous delivery pipeline. So these are stages if you use a tool like Electric Flow, and you go look at the dashboard, and there are stages of the pipeline that are opaque for some reason. Oftentimes that can mean something that, something's going on there that is really a human factors issue. Maybe it's actually people are needing to talk to each other, and that's not really encoded in the pipeline in a way, and maybe it should be, right? But there's always, maybe a little smoke there around that. We see this, I've seen this actually a surprising amount of time, direct subversion of the continuous delivery pipeline. So worked with a client, and it turned out that at the end of the pipeline, so you're thinking, okay, commit, or, build, blah, 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 CI, testing, deployment. It turns out that one of the ops engineers was pulling the binaries out of the pipeline, messing with them, and shoving them back into the pipeline. Now, I'm not saying that engineer is bad, necessarily, but why is that engineer doing that, right? Is there some governance process that to literally do their job, that's what they have to do, right? So again, when we go back to this discussion of socio-technical systems and release engineering, we have to look at a lot of these issues, and this is where you see those yellow flags, right? People doing things that you're like, wait, why are you doing that? And it may not necessarily be, entirely on its face bad. Okay, so this is our human factors sort of elephant, this idea of automate all the things. Who here carries that mantra in their organization? Automate all the things. Yeah, I see a few hands going up. Good. So this is good. But there's a lot, I think, to learn back in aviation, or from aviation here, about automation and their experience with automation in the cockpit. So I'm going to go through a few accidents that I hope give you some food for thought when you're designing automation, really. And the point that I want to make here is when we are designing automation, when we're designing automation for humans to use, these are things that we should be thinking about. And these are lessons that were costly lessons that they learned. And so maybe we might want to take a second look at how we automate things and how we stitch those steps together in a continuous delivery pipeline. So Air Inter Flight 148. So they were descending on a very stormy night, and they had a problem. So these are two different displays. It's the same display in the cockpit, but you'll notice one is a negative 3.3. See that little decimal point? And the other one is negative 33. And those are different modes. So one says, I want 3.3 degrees angle down to descend. And the other one says, I want a vertical speed of negative 3,300 feet. If you're curious in the cockpit, where that is, I've circled it. And if you're having trouble finding it, there's a big arrow to point you to it. But so the problem is they thought they were in angle mode, and they were in feet mode. And it was a stormy night. They were on an approach that they weren't familiar with and had not trained before. And because of that difference, they flew the plane into a mountain. And so the point that I want to make here is a lot of time the instrumentation around the automation, we see what this is called mode confusion. We see that a lot, but a lot of times the automation, have you ever had a script that's doing something and you go run it and it normally takes 10 seconds and it's taking 30 seconds and you're like, huh, what's that doing, right? It's one of these issues. Air France Flight 447. So people probably, this is a more recent one. The safety paradox of automated cockpits, right? And so there are a lot of factors in this particular accident, but the kind of short version of the story is their autopilot had some sensors. The sensors malfunctioned because of weather. And then the autopilot disconnected, and the pilots were giving different inputs. And because they were so stressed trying to debug that situation, they didn't notice they were doing different inputs. And it turns out that aircraft, it doesn't pick one or the other, it averages them. So they canceled each other out, which is interesting. And then it also brought up sort of training issues and are we relying too much on automation? So this is really interesting because it was a situation that sort of caused a bit of a wake up in the industry around how do they use automation? Are we relying too much on automation? Can we fly this plane by ourselves? So, and then the final one that I want to talk about is Air France Flight 296, which is often called the Absheim incident. And so I'm going to show a video here. And if you can't see the video, one of the reasons that I wanted to show this is because the tone in the narrator's voice, I think, is very interesting. So I'll play that.
Aircraft manufacturers have tried to fix that problem by designing the pilot out of the cockpit. This is the first fully automated plane, flown by a computer.
So a couple things I'll point out. I don't know if at the end you heard that kind of squealing noise. I always thought it was music, like suspenseful music. It's not. Those are the engines trying to spool up and ingesting branches and leaves and then stopping. The other thing, though, that I'll point out is the pilots lived through this accident, and which was interesting because they were able to actually interview them and debrief them in a way a lot of these accidents they can't. What they found out is you would probably, in previous eras of aircraft, you would never fly that low at almost stall speed to the ground. That pilot did that because Airbus told him, you cannot stall this airplane. So he said, okay, well, the computer won't ever let me do anything that would stall this aircraft, so I'm going to go do it. And that's what happened. So the point that I want to make that I think is interesting here is when we reason about automation, a lot of times people think, oh, it's automated, so problem solved, right? The last talk had a really good point about, there can be bugs in the automation as well, right? So we need to think about that. Just because we've automated, it doesn't necessarily mean that we've solved all the problems. This is a great video. I'm going to play about a 40-second clip from it. The video is called Children of the Magenta.
Okay, automation dependency. As I mentioned earlier today, the reason this segment is in this course is because as we look at this accident history, what we find is that in 68% of these accidents, automation dependency plays a significant part in leading these crews to either a critical flight attitude or the requirement to extract max performance from their planes. Automation-dependent pilots allowed their airplanes to get much closer to the edge of the envelope than they should have. As we start to study this issue, we decided to take a new tack on this. And so what you're going to hear a lot more at American Airlines is a discussion of what we're going to call levels of automation and technology judgment.
So I think that's really important. Because I don't want the takeaway to be don't automate things or that automation isn't important. It's that we deliberately need to think about automation and levels of automation, and I think technology judgment. I really like the way that this instructor put this. When we're designing these systems, right? It goes back to the human factor and the human element of the operators in the system. One thing I'll point out, did anybody catch the date of this video at the beginning? It's 97. This is 20 years ago. You can find this video on YouTube. It's actually some of the terminology they use. If you look at the human factor system safety area, there's references to situational awareness if you mention that, people might yell at you, which is kind of funny. We can talk about that over lunch. But for being 20 years old, it is remarkably relevant to us today. So if you find this stuff interesting or you're more curious about it, there's a couple of presentations here at DOES that you should definitely go see. These are experts in this field. Dr. Sidney Decker is here. He's going to be speaking later today on a lot of this stuff. And then John Alspaugh, who's done a tremendous amount of work in this area, will be speaking tomorrow on it. So if you find this stuff interesting, check both of those out. So I want to close up with just a couple of takeaways to go back and think about potentially over lunch. So delivery, software delivery, is the focal point of our software systems. That's where all of this stuff really comes together. And because of that, because that's the part that is really delivering the value, there's a lot of meat there for us to look at, right? If you're having, even if you have a continuous delivery pipeline and it's painful, there's a system that's telling you a lot there. And so it's good to really dig into that and find out why. And also that continuous delivery pipeline is not just for computers, it's actually for humans as well. DevOps is not a substitute for release engineering any more than DevOps is a substitute for security engineering, right? So if you're like, well, we're doing DevOps, we don't need security or QA or release engineering, you might want to rethink that a little bit, especially if you're still finding you have hurdles and things. And finally, probably the most important, your release engineering practices must be informed by human factors. So if someone tells you that release engineering doesn't matter, you can have them come talk to me. That's all I got. Enjoy lunch.